So this question, we are told that there is a box sliding on a horizontal floor. Has an initial velocity of 4.0 meters per second. It's a 12 kilogram mass. There's friction. It moves a distance of 4 meters. And 2.0 seconds. We want to know the change in momentum of the box during this time. Now, we could do this using forces, and it might be helpful, but it's not absolutely necessary. So the box moves 4 meters in 2 seconds. So that means that the average velocity is 4 meters in 2 seconds. So that means it has an average velocity of 2.0 meters per second. And if the acceleration is constant, then we know that v bar is v plus v0 over 2. And we don't necessarily know the final velocity, so twice the average velocity is v plus v0. So v then is twice the average velocity minus v0. So the average velocity is 2, and the initial velocity is 4. So we have a final velocity of 0. So the thing came to a stop during that period of time. Came to a stop. And so the change in momentum is m delta v. The mass is 12, and the velocity ended at 0, started at 4. So we have minus 48 kilogram meters per second, a decrease. And we want to know the magnitude. That means don't worry about the negative. So choice B. Now this question, we could not have assumed that it came to a stop because it didn't tell us that. And that's important. This question could have been asked a little bit differently. It could have been traveling at 6 meters per second. And it traveled 4 meters in 2 seconds. And so it would have still been moving at the end. We can't just assume that the velocity is 0 without determining it first.